Sorry about that. My recording device ran out of storage. So let's finish up this example. 52.9 is our perimeter. Now, once I know the perimeter, I can go back and plug it in with the apothem. So that's the next thing I need to find. Now, there's two ways you can do this. Since we know what x is, remember x is approximately 5.3, we could just use Pythagorean theorem. 5.3 squared plus this a for apothem squared equals 9 squared. Or we can use trigonometry again to just use this 9 and that 36-degree angle to find a. Since this is h, a is actually the adjacent side to that 36-degree angle, so we would need to use cosine. Cosine of 36 equals adjacent over hypotenuse. So again, we would cross multiply, and the apothem is 9 times the cosine of 36. And when I do 9 times the cosine of 36, we get that the apothem is about 7.3. And so when I plug in these from my area formula, I'm going to do 1/2 of about 7.3 times that perimeter of about 52.9. And with my calculator, I should get about 192.6 square centimeters for the area of that pentagon. Okay, now part B is pretty similar. We're actually going to save this one to do in class, but part B is a lot easier because I am going to go ahead and tell you how to find the perimeter. The perimeter is 10 times the number of sides, and in this case we have an octagon, and so we would do 10 times 8, so the perimeter is 80, and all we would need to find is the apothem. And we're going to finish this example for part B in class, and so we can move on and get the rest of this covered in the video. All right, that leads me to example 4. In example 4, we deal with triangles that are equilateral. Equilateral triangles are regular triangles. Regular meaning all sides are congruent. So there's two ways that we can solve for the area of each of these triangles. We can use our regular polygon formula still. Sorry, that's a different way of writing it. Okay, we would need to know the apothem. We can find the perimeter real easily because it's just 14 times 3. And 14 times 3 is 42. We need to know the apothem. Well, we're using this triangle within the triangle. Okay, I'll highlight it for you so you can see what I'm talking about. All right. So I've got this triangle where A is for the apothem, and then this length would be 1/2 of 14, or 7. Now, this is a special right triangle, and I'll show you why. When I work on my central angle, okay, that central angle is 360 divided by 3 for the number of sides. And that's 120. But this angle that I'm using here is 1/2 of that 120, so that angle is 60 degrees. 1/2 of 120 is 60. Since that's a 60-degree angle, this has to be 30 degrees, and it's a special right triangle where this is actually the long leg. So we would actually divide by the square root of 3 to get the short leg, if you remember your special right triangles. Now, we could still use trigonometry to find that. Using this leg to find the other one, we would need to use tangent. But I'm going to allow us to take a shortcut. So the apothem in this case is 7 over root 3. And you might remember that no, we shouldn't leave it that way, so we're going to go ahead and make it 7 root 3 over 3. Either way is writing, that's fine. Perimeter is 42, and so we can just do 1/2 of 7 root 3 over 3 times 42. And then when we simplify all that, I'm going to show you something kind of neat. 1/2 times this 7/3 part is 7 over 6. Okay, we can multiply that 2 and the 3. So 7/6 root 3 times 42. 7/6 of 42. 42 divided by 6 is 7. And 7 times 7 is 49. So we can enter it in our calculator a lot easier now if we just do 49 times the square root of 3. That's what the area of this triangle would be. And 49 times the square root of 3 is approximately 84.9 square meters. But I did tell you there's a second way we could do this. If you think of this as a triangle, and just draw in your height of the triangle, we can use our area formula for triangles of base times height divided by 2, where the base in this case is 20. The height we would need to find using special right triangles. Again, it's not going to be the same as this apothem. It's a different part of that special right triangle, different size, and then divide by 2. And we'll look at how to do that part of it in class. So this wraps up our videos. Hopefully this wasn't too confusing. We will cover any questions on Monday.